Hello everyone. Guys, please confirm once, am I audible and visible to you? Shillong, guys, can you hear me? Please share your attendance. Okay. So guys, tell me, how was your holidays? Have you enjoyed that? And please mark your attendance once. Okay. So guys, first of all, tell me, how are you? What's going on? Is all good? And please share the topic that we were discussing in the previous class. Guys, what was the topic that we were discussing in the previous class? I have given you some homework as well. Have you completed that? Hi, good evening, Senapati. How are you? Guys, please share topic. Atomic radius was the topic going on. Okay, there are 4 types of atomic radius. Van der Waal, and then covalent, metallic, and the ionic. And I think so we have discussed about the 3. Ionic radius is left, that we haven't discussed yet. We were discussing few important points regarding the covalent and van der Waal and the metallic radius, I guess so. That was the topic was running in the last class. And I have told you to learn those 50 elements that I have discussed with you. The tricks I have discussed with you. Guys, have you done that? Shillong, guys, have you done that? Today we have to discuss one more group. Hi, good evening, Senapati. Am I audible to you, Senapati? Shillong, I have asked you something. Guys, first of all, tell me that, have you completed that? Shillong, can you hear me? I have asked you something. Will you answer that? Have you completed the homework or not? What about you, Senapati, in Tetso College? Hi, Itanagar. Okay. So in the last class, I have discussed how to learn S and P block elements. Today we are going to discuss about the D block elements. Okay. So guys, I have give you the rough idea that how periodic table look likes, and in the periodic table I have discussed S and P block completely. Okay. So today, first of all, we will learn about the D block element, that how we can memorize the D block elements. Okay. So there are D block elements. And after that, we will continue with our ionic radius. See, P1, 2, 3, 4, 5, 6, 7. Your D block starts with period 4 and ends up at period number 5. Sorry, period number 7. Okay. So guys, ultimately in the D block we have to learn about the 4 periods only. The important point is that D block starts with the period number 4, and it starts, if I talk about the columns which are groups, it starts with group number 3 up to group number 12. So actually D block starts from group number 3 up to group number 12. In periods, it starts from period 4 up to period 7. So guys, this is the idea regarding the D block elements, that you have to remember that D block will start with the group number 3 and it will end up at group number 12, whereas if I talk about the periods, it will start with period number 4 and it will end up at period number 7. Okay. So this time we will learn these elements horizontally, means period wise. In the first 2 blocks, which is S block and the P block, we have learned the 2 blocks vertically, means that we have remember them group wise. Okay, but here we will learn these elements in the period wise. Okay. So guys, let's begin with the period number 4. Period number 4, and the elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, cobalt, nickel, copper, and zinc. So guys, these are actually your period number 4 elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. If I talk about the atomic numbers, scandium has atomic number 21. You have to just remember the first atomic number of the element. After that, you will to just move on by adding +1. This is 22, this is 23, this is 24, this is 25, this is 26, 27, 28, 29, and 30. Okay. Scandium belongs to the group number 3, whereas zinc belongs to the group number 12. Okay. If I talk about that how we can learn it. So guys, this is the mnemonic for this one. This is your Scotty. Okay. Scotty is the name of a person. Visit chroma. main. Chroma means feeling cold, feeling cold in. Guys, this in is just addition to it. Okay, this is not name of any element. In in this is you have to remember this name, Niku. Niku is a combination of nickel and copper zone, which is the zinc. So guys, this is this Scotty visit chroma. Chroma means feeling cold in Niku zone. Okay, so you can memorize this one. Or I have told you that you can make your own mnemonics as well. Okay, so please copy this once and just confirm me that you have copied that. Please confirm me once that you have copied that. Okay. What about you, Itanagar, Shillong, Tetsu College? Guys, have you copied that? Copy please quickly. Shillong, Tetsu College, Itanagar. Guys, have you done that? Okay, so let's move on. This is period number 5. Yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, and cadmium. Okay. So these are the elements which are present in the period number 5. Now, how we can learn this? First of all, let's see the atomic numbers. It starts with 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Okay? Now, see. This is your U, Zara, Nabi, and Molly. Okay, wait a minute, Sisipo. Take rude, rhino, paid, silver card. Guys, AG is the symbol for the silver. Okay, Sisipo has some other mnemonic as well. Guys, you can please copy this. Sisipo has prepared its own mnemonic. Scolding Tinu is very cruel, but Minu feels cool in nightclub zone. Yeah, that can also be possible for the previous one. Okay. Please copy this. After copying that, please confirm me once. Can I have one active person on the system so he or she can at least reply quickly that whether the whole class has done or not? Okay. Sisipu, Itanagar, Tetsu College, guys, have you done that? Okay. So guys, this is the period number 5. Let's move on to the next one. See. Period number 6. This is your lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, and mercury. Okay. The important point that you have to remember that atomic number of the lanthanum is 57. But guys, the series means the next elements break here and they goes to the F block elements over there. Therefore, the atomic number of hafnium is not the 51. It is actually your 72. So you have to remember in the D block elements, there is a break. Okay. So after the 57, you have to directly jump to the 72. 73, 74, 75, 76, 77, 78, 79, and then 80. Okay. So this is the hi, good evening, St. Joseph. So this is the guys at how you can remember the atomic numbers. Okay. This is a quite different over here. You have to remember simply. And now let's say it's mnemonic. What can we do with this one? This is your large, high tension wire on industrial plots and highway. So guys, you can use this one to remember this. And if anyone has some different mnemonic for this one, you're most welcome, guys. Please do share with me. I'll update that one as well. Okay? First of all, please copy this, and after copying that, confirm me once. Okay. What about others? Sisipo, Shillong, Senapati, Saint Joseph. Guys, have you copied that? Okay. So guys, let's move on to the next one. Period number 7, which is the last period of the D block. Okay. Guys, you can copy this one along with me. Okay. So these are the elements over here. Now you can remember these elements. And first of all, guys, you have to remember this one, that the atomic number of actinium is 89, but rutherfordium is 104. Again, there is a series break. Okay. So you have to remember that actinium is 89, then rutherfordium will comes out to be at 104. Then dubnium, seaborgium, bohrium, it will continue. Okay. So 105, 6, 7, 8, 9, 110, 111, and 112. Yes, Isabor, it can be, but the point is, try to use least connectors in the one sentence while we are preparing the mnemonic for learning the elements. Okay, because they might create the confusion. But yeah, this one is a very good attempt. If you can remember by the help of this one, you're most welcome, guys. Okay, you can please keep this one. Okay, and let me write for this one. Yeah, you have good one for this one, period number 7. So you are most welcome. Yeah, this one is also very good. Good attempt. This is your ACE, R, D, Sharma, book has I hope so everybody has heard about the R.D. Sharma. Has maths difficult or we can say maths doubts and right corrections. Please copy this one. So guys, how many more elements we have covered? 50 in the previous class. Right now, how many elements? D block series is over. Okay, so we have covered the 90 elements out of 118. So we are left with only 28 elements. Okay. So guys, please leave some spaces as well. Okay. In the next class, we will cover the next F block element. Okay. And I hope so you're memorizing all these elements, guys. This is gonna be the very helpful. Okay. In your school examinations, or we can say your higher examinations for your, we can say the entrance examinations as well. Okay, those who are preparing for the entrance examination, this could be very helpful for those. Okay, and confirm once after copying that. And yes, this improves your knowledge as well. Okay, so for your knowledge, it would be better that you learn all these elements. Okay, Shillong, Sisipo, St. Joseph. Guys, have you copied that? Itanagar. Yeah, this one is really good. Very good, Sisipo. Okay, so guys, that's all about your SPD block elements. Okay, we have covered the 90 elements. So now let's get back to our syllabus. Okay, this is also the part of the syllabus. Don't think that this is not in the syllabus. Now, I guess so we have discussed that. We were discussing about the atomic size. We have already discussed that on moving down the group atomic size increases because shells increases, or we can say nuclear charge decreases. Okay, because shells increases or nuclear charge decreases. Okay, if we talk about on moving left to right, left to right, size decreases because nuclear charge increases. Okay, I think so. We have written these 2 points in the previous class. If not, you can please copy this. For those who haven't copied in the previous class, guys, please tell me that I have covered this one in the previous class. That's what I remember that I have already discussed with you, this one. Okay, so on the basis of this one, we can say that group 1 elements has larger size than group 2 elements. Okay, and on moving from left to right, we are talking about in general. Okay, this is in general, that group 17 has the least side. This is in general. In general. Okay, group 1 in the periodic table, group 1 element has the largest size, whereas group 17 has the smallest size. Okay, this is decreasing in this manner. Now, if I talk about group 1 element, group 1, if I arrange them in the order of increasing size, we will say lithium, sodium, potassium, rubidium, cesium. Okay, francium is a radioactive element, that's why we won't consider of that element over here. Okay, this is the order for the group 1 element. Similarly, you can write it for the group 2 element as well. Okay, now I am discussing for the group 13 element, which is boron, aluminium, gallium, indium, and then thallium. Okay, last one again is a radioactive element, that's why we won't consider that. So guys, this one should be the correct order for the group 13 element, but unfortunately this is not the right answer. See, this order is not correct. Okay, this order is not correct. First of all, copy this and then we'll discuss why this order is not correct. Copy this. We'll see its correct order. Copied? Hey guys, have you copied that? Shillong, Sisepo, Senapati, St. Joseph, Itanagar. Have you copied that? Okay. So guys, first of all, let's write the correct order. The order is boron, because it is not quite possible to determine their atomic sizes. Okay, these are the some free elements which emits the radiations. Okay, so their study is very difficult. Even their half-life is very short. Okay, that's why we do not have any much appropriate data regarding the radioactive elements. That's why we are not considering those elements over here. Okay, so this is your gallium, aluminium, indium, and then thallium. Guys, we can see a swipe. See, in the previous order, according to the order, that gallium has a bigger size than the aluminium, but this is not true. That gallium has a smaller size than the aluminium. Guys, this is very much important, even with respect to your school examinations. Okay, this is the order. That boron, after the boron you will get the gallium, aluminium, indium, and then thallium. Okay, if you do not remember this order, you can simply learn this order and just remember that you have to swipe aluminium and the gallium. That's it, and that's it. Rest elements would be the same. Okay. Now, what was the reason for that? Guys, we will learn about a point which is lanthanoid contraction, which is not in our syllabus right now. Till then, you have to just remember a word for this one. Due to lanthanoid contraction, you can say, or you can say due to poor shielding of d orbital. Okay, this is the reason for the gallium, that due to the poor shielding of the d orbital. Okay, guys, remember the shielding effect decreases in the order. I think so. Shielding is already discussed with you. Excuse me. The shielding depends on the type, on the shape. Okay, the kind of shape S has, which is a spherical shape. So the shielding effect, we can say they can shield the nuclear charge more effectively as we compared the S orbital with the P, D, and F. Similarly, if I talk about the P, due to its shape, P can shield the nuclear charge more effectively as I compared that P with the D and F. If I talk about the D, then D can shield much better as we compared with it the F block. If I talk about the F, F has the least shielding, okay, due to its shape. So guys, in the gallium, just before it, d orbital is included over there, due to which there is inner d orbital electrons. See, let me make some more clarification on this one. Okay, suppose this is your 3D and this is your 4S. Okay, guys, look at this. Net, if I talk about net, there is interactive force, means net force is towards the inwards, which is by the nucleus. Now, if I talk about the 3D over here, that 3D has very poor shielding. Shielding means that it cannot shield the nuclear force. Okay, so if it cannot shield the nuclear force, then obviously nucleus will try to pull the 4s electron more effectively towards itself. So if net nuclear force is higher at the 4s, obviously this scenario will happen over here, that 4s electron will shift slightly towards the inner side, and due to which its size will decrease. See, the black line represents the original size, whereas the red line represents the new size, okay, which is obtained after calculating the net nuclear force, and net nuclear force on the 4s has increased due to the poor shielding of the 3d electrons. Okay, so this is the reason why gallium has a smaller size. Okay, and this is the experimental phenomena, and this is explained by the help of experiments. Okay, so I'm telling you the how actually they have determined that why its size has decreased. Okay, so guys, first of all, tell me that is it clear to everyone that why size of the gallium has decreased? Any point of confusion or doubt? You can simply remember that due to the poor shielding of d orbital electrons. Any confusion or doubt? Due to the poor shielding, the net nuclear force is very, very high in case of gallium. This is for the gallium. Okay, see. Guys, look at this. This is your aluminium, this is your gallium. Okay, if I talk about naturally, so obviously on moving down the group, the size of gallium should increase. Okay, the size of gallium should increase. But the point is, see, in case of gallium, 3d electrons, or we can say 3d orbitals are filled first. Okay, now if 3d orbitals are filled first, see, I'm drawing two scenarios like this. This is your gallium. Okay, and this is your gallium. Okay, if we look about the aluminium, which is atomic number 13. Okay, the configuration is 1s2, 2s2, 2p6, 3s2, 3p1. Guys, look at this. The inner orbital is 3s and outer orbital is 3p. Okay, if you talk about the gallium, you can write its configuration. You will find out that the inner orbital is 3d. If I talk about gallium, inner orbital is 3d and outer orbital is 4s. Okay, now when you compare gallium with the aluminum, guys, if you talk about the nuclear force, which is not very different from each other. Okay, they are quite similar, we can say. Okay, the net nuclear force is quite similar if I talk about in terms of the values. Okay, now the point comes, the inner orbital in case of aluminum is what? 3s. I think so I have discussed about the shielding or the screening effect. Okay, S has the spherical shape. So if it is a spherical shape, actually S will present like this in this one. This is just for understanding, guys, just for understanding. See, obviously nucleus is pulling the outermost electrons towards itself. So what's happening over here? The 3p is being pulled by the nucleus. Okay, but guys, there is, if I talk about inside is 3s is present over there. So the capability of shielding the nuclear force, ultimately I'm saying that the 3s will prepare a wall which will actually resist the nuclear force to act upon the 3p. Obviously 3p will feel some force of attraction, but due to this wall, it won't feel much attractive force. Okay, but now if I talk about this one, guys, the shape of 3d, if you remember, is double dumbbell. Okay, so guys, due to this shape, the inner wall, I'm talking about this one, the inner wall, obviously again nucleus is pulling the outermost electrons towards itself, but guys, the point is the inner wall is not strong enough to resist, or we can say to make a effective wall which resist the nuclear force. So what's happening, that the nuclear force being felt by the 4s orbital is very, very high. Okay, so what's happening, that here in case of aluminium, the nucleus is not very effectively pulling the 3p orbitals towards itself, Whereas in case of the gallium, the nuclear force is very, very high. So due to very high nuclear force, it will pull the 4s electron towards itself very forcefully, and due to that force, the 4s electrons will actually shift slightly inner side. Okay, so guys, again the black line representing the original size, whereas the dotted green line is representing the new size. Okay, which is actually obtained when we have calculated the net nuclear force which is experienced by the whole atom, or we can say the outermost 4s orbitals. Okay, so ultimately the size factor depends on the nuclear force. Okay, if nuclear force is very high, and guys remember one thing, please do not say that sir at the bottommost element nuclear force should be very high. No guys, we know that size of the nucleus is increasing, but the distance from the nucleus is also increasing. Okay, if distance from the nucleus is very high, then nuclear force will not dominate over here. This is the case which is obtained experimentally. Ultimately they have examined this and they find out that gallium has a smaller size than the aluminium, and when they performed the experiment, they came to know that the inner orbital, 3d orbital, has the poor shielding, due to which its size decreases. Okay, whereas the size of the aluminum remains the natural which we were expecting. So ultimately the size of gallium has decreased, whereas the size of the aluminum is natural. That's why we obtained that gallium has a smaller size than the aluminium. Now is it clear to you? After the whole story, is it clear to you, or it is just like a story? Okay, guys, yeah, there is one more important question. Why we are not observing it with the other groups? Remember guys, this is only observed when we just started with an element where d orbital has just introduced. Okay, this will obviously act on the other elements. Let's say suppose if I talk about the group 14, but their dominancy of skinning effect or shielding effect is not very high. That's why this is not observed over here. Okay, so this is specially observed in case of the group 13 elements. Am I clear? Shillong, are you clear with your doubt? Guys, please tell me, is it clear to you that why gallium has a smaller size than the aluminium? Guys, are you sleeping? Sisipo, Senapati, and Itanagar, Tetsu College, guys, are you there? Oh, is it clear to everyone? Shillong, Senapati, Sisipo, Itanagar, guys, is it clear to you? Why is this happening? And this order is very important. Very important. Okay, हाँ sir, बहुत बढ़िया. Please copy this order. Copy this order. Oh, it's been a long time that I have heard that word. हाँ sir. Okay, you're not sleeping, then say Jai Bhadrakali. Those who are not sleeping, say Jai Bhadrakali. Write it. Yeah, you can say in your classroom as well. Oh, great. By the way, that is Jai Mata Di, not G. Okay, so guys, let's move on. Okay. Guys, one important thing that in the inorganic chemistry, I know we have to deal with the exceptions, but I think so I have explanations for the many of the exceptions. Okay. So, with your doubts, you're most welcome, and even I'll start giving you sheets as well. okay, on the basis of the lectures, and you have to solve those sheets as well. Okay, that is just for the practice. And I hope so that we will perform very good in examinations. And I have told you that please do share your doubts with me if you have any. You're free to ask me in the groups and yeah, in the lectures as well. Okay. So guys, let's begin. Also, finally, there are two centers, Shillong and the Sisebo. The centers are, I think, sleeping. So, Senapati, Itanagar, Tetso College, they have just disappeared. Hi, good morning, guys. Okay, so guys, that's about the atomic size. Okay, this is about the atomic size. Now let's move on to the I'm not getting your point, Shillong. You wanna ask me something? Okay, it is not still clear to me. Can you please write a single sentence? I'll move on to the ionic size or ionic radii. Can we start? So guys, the next topic is the ionic radii or the ionic size. Okay, first of all, let me clear this one. What does it mean? And guys, remember one thing. See, this is your cation, and this is your anion. Okay, cation, anion. Okay, the distance, this distance, I'm writing with R. Okay, this is your RC and this is your RA. Okay, C stands for the cation, whereas A stands for the anion. So, if I talk about the radius of whole lattice, or I can say the ionic radii, this will be sum of the radius of anion and radius of cation. This is the formula for this one. That ionic radii is the sum of the radius of cation and the sum of the radius of anion. Oh, sorry. I mean to say that ionic radii is the sum of radius of cation and the anion. Okay. This is the formula for this one. And now after that we have to discuss a few important points regarding the ionic radii. Please do copy this quickly so we can proceed. Cool. Let's move on. Guys, in the examination, many questions will be, there is a possibility to ask many questions from this particular section of ionic radii. First of all, let us discuss about the cation. There is a question which is very common in the school examinations. Why size of cation is smaller than its parent atom? See, I'm taking example of this one. This is sodium and this is its cation. Okay. If I compare size of sodium with sodium plus, obviously according to the statement, the size of sodium should be greater than Na plus. And this is always true, that size of cation will always be smaller than its parent atom. Now the question is why? Can please anyone give me a small answer for this one? A short answer for this one? Last time many of you have said that you have already discussed it in your schools. Can anyone please tell me? Yeah, that's quite good. What's your name at the Shillong Center? Yeah, Kohima, you are there? I was missing you. I'm very happy to see your name on the screen. Okay, yeah, quite good answer, Shillong. What's your name? Who said this? Who said this one? Okay, very good, bro. I mean, dear. Yeah, that one. Okay, guys, let's begin. First of all, let me clear the concept. Okay, everyone. Okay, that's good. Okay, guys, first of all, let me clear the concept, and after that, I'll write the explanation for this one. Guys, look at this very carefully. Okay, we can say that. Okay. First of all, please do not copy this one. You have to just simply look at this. Guys, please, I need one person on the chat screen, or I mean on the system, who will answer me quickly by the concern of whole students, whole class. Okay, guys, this is the person A, and this person A is pulling the 4 other persons. Okay, this is the first scenario, that the person A is right now pulling the 4 persons towards itself. At the same moment, these 4 persons are pulling the A. Okay, ultimately, they are pulling A towards itself, whereas A is pulling these 4 persons towards itself. Okay, now I am drawing the second scenario. See. This is the second scenario. Again, this is the person A. Please tell me in which case person A can apply more force to the other person. This is the person A again. Sorry, this is not B, this is A. I'm asking, in which case person A can apply more force? In the second case or in the first case? Okay. Think about it. Okay. Okay, good. Okay. Shillong, will you say something? आप अपने कुछ विचार व्यक्त करना चाहेंगे यहाँ पे? Shillong. Good. That's what exactly happening over there. See? In case of sodium, the protons were 11, but electrons are also 11. But in the second case, protons were 11, but electrons were 10. In the first case, 11 protons are pulling the 11 electrons towards itself, whereas in the second case, 11 protons are pulling the 10 electrons towards itself. Obviously, the force of attraction will be little bit high in case of cations. That's why the net size of the cation decreases. Okay, so guys, I'll write explanation for you. 1 second, I'll write on this page. You can copy this one along with me. Okay, first of all, copy this one. Copy this one, Na and the Na plus, comparison of Na and Na plus, and after that I'm writing the whole explanation. And guys, remember, I'll take the similar example in case of anions. Okay, copy this one. Guys, is it clear to everyone? Everybody is understanding the concepts? Okay. Okay guys, so let's begin. You can copy along with me. Okay, Sisipur, I'll talk about it regarding this one. Okay, I'll update you on this one. Okay. Till then, I'll give you the sheets. You can solve those sheets till then. Okay. So, guys, what I was writing: size of cation is smaller than its parent atom because after losing electron, net nuclear force increases. Guys, very, very important with respect to school examinations. Even the second part as well. Why size of the anion is bigger or higher than its parent atom? Okay, this is the question number 2. Next question. Why size of anion is higher than its parent atom? Okay, I'm taking the example. I'm comparing Cl have gained 1 electron to form Cl minus, and I'm saying that please copy this. If you have cleared with the concept, then I don't think so that much clarification needed on this one. See, size of Cl minus would be greater than size of Cl. Okay. If I talk about the protons, it has a 17 protons. This one is also has a 17 protons. But if I talk about electrons, it has got 18 electrons and this one has got the 17 electrons. So guys, in the same scenario, assume or imagine that particular person who was initially pulling the 4 persons, whereas after some time one more person added over there. Now the single person is pulling the 5 person towards itself, and in the other scenario the same person is pulling the 4 person towards itself. Obviously the net force of attraction will be higher in case of where it is dealing with the 4 person. Okay, where in case of the 5 persons the net force will decrease. Same happens over here. Okay, you can please copy this, and after that I am writing the explanation for you. And again guys, this is very, very important for you, that this is important for your school examinations as well. Okay, so I am writing the explanation for this one. Why size of anion is bigger than its parent atom. Size of anion is higher than its parent atom because after gaining of after gaining of electron, net nuclear force decreases. Please copy. Okay. How many students are there at the CCPO center? Guys, have you finished that? Parent means parent means from the atom which is it is being generated. See, Cl minus will be obtained from Cl. Okay, so here Cl is the parent. Okay, if I talk about this one, see, Na plus, you can write one electron over here as well. Na plus is been obtained from Na, therefore Na is the parent. Okay, is it clear to you? Shillong, have you copied that? Shillong, Senapati, Itanagar. Guys, have you copied that? Okay. So guys, you need a break or we can continue? Okay, let's take a break of 5:10. I'll see you at 5:20, sharp 5:20. Hi guys, back again. So guys, how was your break? Break is over now. Is everybody has joined the class? Or still there are some students at the break? Shillong, Tamenglong, Sisipu, Kohima, Senapati, Itanagar, Tetso College. Guys, have you joined the class? What about you, Shillong? Sisipu, are you done with your break? My dear student, at the Shillong you are sitting like this. You can use your fingers to type on the keyboard to say yes or no. Better. Okay, any point of confusion or doubt? You want to ask me anything? Anyone wants to ask me anything? Okay guys, so let's move on, okay? Now the next important point. For isoelectronic species. Okay? So guys, for the isoelectronic species, you have to just remember that as the nuclear charge increases, the size will decrease. Okay? See? What are we comparing? I'm giving you, actually I'm discussing a question with you. Okay? Just look at the question. Then after that, I'll give you time to copy that. See? Question is, arrange the following in the order of increasing size. And guys, before that, before the question, you can make note of this one. Okay. For isoelectronic species. Before doing that question, you can remember this one. For cations, charge increases, size decreases. For anions, charge increases, size also increases. Please copy this one. We will use it. Copy this one. Shillong, all the students are back? Is all the students are back? Wow, there are some students are still at the break. They are enjoying their break. Wow. Acha, okay. Please copy this. Copied. And what is the final attendance at the Shillong Center, Kohima Center, Sisipu? Okay, Sisipu, I have got your attendance. Senapati, what is the final attendance? Okay. Okay guys, let's do that question. In the question, we will have Na plus, Mg2 plus, N3 minus, O2 minus, F minus, Al3 plus. Okay. So guys, this is the question. First of all, you can check all the ions given to you are isoelectronics, means all the species has the same number of electrons. In that case, the question become very, very simpler for us, that we have to simply remember cations will always have smaller size when we compared with the anions. Okay. So first of all, you can separate the cations, you can separate the anions, and you can arrange the cations and you can arrange the anions, and then simply you can pair them. Okay. See, in the cations we have got Na plus, Mg2 plus and Al3 plus. We have written over there that for cations charge increases, size decreases. So obviously guys, if I talk about this one, see, Al3 plus, in case of the aluminium, it has got the 3 plus charge, that's why its size will be the least. Okay, because charge is maximum over there. Al3 plus, Mg2 plus, Na plus. Okay, that's all about your cations. Then let's start with the anions. In case of anions, we know that as the charge increases, size also increases. Therefore, F minus has the least charge, therefore its size will be least among the anions. Okay, but obviously it will be greater than the cations. Then O2 2 minus, and last one will be N3 minus. Guys, please tell me, anybody has had any confusion or doubt regarding this question? Anyone has got any confusion or doubt? Please copy. Okay guys, so let's practice a few little questions. Question is, you have to arrange all of them in the order of increasing sizes. Fe, Fe3 plus and Fe2 plus. Okay, 1, 2, Mn7 plus, Mn3 plus, Mn 4 plus, Mn minus, Mn 2 minus. Attempt this question, guys. After attempting that, you have to just tell me you have done that question, then I'll discuss this with you. Guys, this is Fe, not F. This is Fe in question number 1. increasing. हो गया? Are you done with that? Okay. How many students are there at the Kohima Center? Shillong, Senapati, Itanagar, Sisipu. Okay. Okay. So guys, let's discuss this question. Please check out your answer. One second. I'm writing answer here first. Order was increasing, so this should be the right answer. Okay, for the number 2. Mn 7 plus will have the least size, then Mn plus 4, Mn 3 plus, Mn minus and Mn 2 minus. कितने लोगों का आंसर ठीक है? How many of you has got the right answer? Same? Seriously? Okay. Congratulations, Sisipu. Done. सबके सब बहुत नाइंसाफी है ये. सबके सब का आंसर ठीक आ गया. Well done. High five to all those students who has got the right answer. Okay. So guys, I'm sure that you're able to solve these kind of questions. Okay. So let's move on to the next topic. Next one is your ionization energy. Or also known as ionization potential. You can say potential or enthalpy as well. Enthalpy. Okay. So guys, first of all, understand the meaning of ionization. See, whenever you remove an electron from a species, okay, so to remove that electron, the energy supplied by you is known as what? Ionization energy. Ultimately, to convert that particular species into ion, okay, is known as what? Ionization energy. See, Let me clear this definition. This is the electron to you. You have to remove this electron. So obviously to remove this electron, you have to supply some energy to it. Okay? And after supplying the energy, this electron will move away from this atom. Okay? Means the influence of the nucleus over the electron will be finished after supplying this energy. Okay? So basically, to remove an electron from a isolated gaseous atom, this is the main line ultimately. The main point from the isolated gaseous atom is known as what? Ionization energy or the ionization enthalpy. Okay? So guys, first of all, clear this one, that to remove most loosely bonded electron or outermost electron, the energy supplied by you in the isolated gaseous atom is known as what? Ionization energy or the ionization enthalpy. Okay? Now, I'm writing its a definition. The minimum energy required to remove an electron from isolated gaseous atom. Guys, remember, if you won't write this isolated gases word, you won't get the whole marks. Okay? First of all, to remove the electron, one more important thing, guys, to remove, please add this one as well to this one, add this one as well. Most loosely bonded, to remove most loosely bonded or we can say outermost. Okay, so this is the main line, that isolated gaseous atom. Okay, so guys, to determine the ionization enthalpy, first of all, the atom should be isolated, means it shouldn't be in the bonded state. Okay, it should be in the gaseous state, and in that particular state, the energy supplied by you is known as what? Ionization enthalpy. Please copy this and tell me, is there anyone who has got any doubt or confusion? Want to ask me anything regarding this one, regarding the definition? Anyone who wants to ask me anything regarding the definition or any point of confusion in this statement? Okay. Isolated means it is not bonded to any other atom. Single atom. Single atom in the gaseous state. That is the meaning of isolated gaseous atom. Means free state. Are you clear with your doubt? This is not V. This is just a symbol, dear. This is not V. Actually, this is the arrow that you have to add this line. You have to add this line. This is not V. The minimum energy required to remove most loosely bonded or outermost electron from isolated gaseous atom. Have you copied that, everyone? Shillong, Senapati, Sisipu, Kohima has done that. Itanagar. Okay. Any doubt? Cool. Let's start. Guys, look at this and please reply as fast as you can. I mean to say that first of all think about it and after that you have to reply. Okay. This is atom A. I have removed one electron from it. Okay. In this case, the energy supplied by you is known as the ionization energy 1. I am removing one more electron from it, and after removing that, it will develop +2 charge. This is known as your ionization enthalpy 2. I am removing one more electron. Obviously, it will develop +1 charge more, so it will be A3 plus, and this is your ionization energy 3. Ultimately, what I am trying to say that if I am removing electron from the same species again and again, so this is known as the successive ionization energy. Successive ionization energy, or we can say successive ionization enthalpy. Okay, first of all, clear the meaning of successive. Successive word will always be used only when we remove the electron from the same species again and again. Okay, now my question is, if I compare ionization energy 1, 2 and 3, which one will have the highest value? Means in which case you need maximum energy to remove the electron, in case of ionization energy 1, 2 or 3, or we can say that which ionization energy has the highest value, 1, 2 or 3? Okay, I have got one answer. What about you guys? Kohima, Senapati, Sisepo, Itanaga. Okay. Let me clear. I think there is some confusion. Some of you has given the right answer. Guys, think about it. See, in one case electron is present here. This is the second electron, this is your third electron. We have to remove 3 electrons, okay? I have to remove this electron, and this electron. Think about it and tell me where nuclear force will be maximum. This is 1, 2 or 3. Where will be maximum nuclear force? At 1, 2 or 3? Very good. Obviously, at 3 we will have a maximum nuclear force. When I'll remove this electron, this is your ionization energy 1, this is ionization energy 2, and this is your ionization energy 3. So obviously, when I'll remove the third electron, it will be much more closer to the nucleus, therefore I need to supply much more energy. That's why here ionization energy 3 will be very, very high and ionization energy will be low as compared to 1 and 2. Sorry, as compared to 2 and 3. I hope so it is clear to everyone. Please copy it. Those who has got the doubt, I'm sure that it is clear to you. If it is not, you can guys ask me. I can take another example as well. Please copy. Okay. Good. Is there anybody who knows the meaning of Shashtant Dandvat Pranam? Anyone there who knows the meaning of this particular sentence or word? This is actually a single term. Shashtant Dandavat Pranam. That's what I mean. You can think about it by the time I'll start the new topic. See, this is the ionization energy. And those who has got the answer, you can reply on the screen. What is the meaning of Shashtant Dandavat Pranam? Okay. Now, factors affecting ionization energy. Can we start? No. Okay. Factors affecting ionization energy. First of all, let us discuss about the size. How size affects this one? Size. Guys, please tell me, what will happen to the ionization energy? Will it increase or decrease on increasing the size? Size is increasing. Please tell me, what will be the effect on the ionization energy on increasing the size? Okay. Yeah, good. Guys, obviously, if size increases, it means that nuclear force is decreasing. If nuclear force is decreasing, obviously, the outermost electron feeling very low force, therefore, it is easy to remove. So, we have to simply remember that with increase in size, ionization energy decreases. Okay. Number 2. Nuclear charge, or we can say the nuclear force. Better word is nuclear force. Obviously, if nuclear force is increasing, it means that outermost electron is feeling very, very high force. It means to remove the electron, we have to supply high energy. So we can say that as nuclear force or nuclear charge increases, ionization energy also increases. Please copy. I'm good. Oh, I think this is the answer for that particular statement. No, it is not like that. I'm giving you time. Find out the meaning. Copied? Kohima, Shillong, Sisipo, Senapati, Itanagar, Tetso. Guys, have you copied that? Next. Shielding or screening effect. Or screening effect. I have already explained you what does the shielding and screening effect means, but I'm just giving you the brief picture of that again. See, just for the more clarification. This is the electron. Yeah, exactly. You are absolutely right, Kohima. Okay. Okay, guys. Let's focus on the topic. See, this force of repulsion ultimately Due to the inner electrons, the outermost electron will definitely feel some force of repulsion. Okay, and due to this force of repulsion, the net nuclear force on the outermost electron has decreased by the nucleus. This nuclear force has decreased by the nucleus. So guys, this force of repulsion, or we can say the shielding by the inner electron, is known as what? Shielding or the screening effect. Ultimately, you can say that after feeling the force of repulsion by the inner electrons, the net force experienced by the outermost electron is known as what? Net nuclear force. And if inner electrons are very, very high, it means that force of repulsion will be very, very high. If force of repulsion is very, very high, it means that it would be easy to remove the electron because nuclear force will decrease. Guys, I'm repeating what I was saying because I have discussed this already in the detail. I'm saying if inner electrons are high, outer electron will feel the more repulsion. If it feels the more repulsion, nuclear force will decrease. If nuclear force decrease, it means ionization energy will also be decrease. I think I'm clear with my statement. You tell me, have you got this concept? I have to write this one. If shielding or screening effect increases, ionization energy decreases. Guys, please copy this and tell me, is it clear to you? If anyone has got any confusion or doubt regarding the statement, you can please tell me so I can take another example to explain this one. Is it clear to everyone? Shillong, Senapati, Kohima, Sisipo, guys, Tetso. Okay. Means if shielding or screening effect increases, it means that the nuclear force will decrease. If nuclear force decrease, it means obviously ionization energy will be decreased. Okay, that's good. Next. Electronic configuration. Guys, please do one thing for me. I'm comparing nitrogen with the oxygen. Obviously, nitrogen has the atomic number 7, oxygen has the atomic number 8. In the periodic table, oxygen is the exactly next element to the nitrogen. I'm comparing the ionization energy. Please tell me which one should have the highest ionization energy, nitrogen or oxygen? Nitrogen or the oxygen, which one will have the higher ionization energy? According to the concepts that we have discussed. Okay. Okay. Why Senapati? Can you give me some little explanation? Means short explanation. शिलोंग, आप कुछ नहीं कहेंगे? What about you, Sisipu? What are your views regarding this one? On comparing the ionization enthalpy of nitrogen and the oxygen, which one should have the highest ionization energy, higher ionization energy, and why? Okay. Those who are writing the nitrogen, can please tell me why nitrogen should have the higher ionization energy? I'm telling you that nitrogen comes before the nitrogen, and we have discussed that on moving left to right, nuclear force increases. So if nuclear force is increasing, so obviously oxygen should have the higher nuclear force. If oxygen has the higher nuclear force, it means that oxygen should have higher ionization enthalpy. Why you are saying the nitrogen? Those who are saying the nitrogen. Are you clear with my explanation? Please do not copy this. I'm not saying copy this. I'm just asking you, why are you saying the nitrogen? Concept says that on moving left to right, nitrogen comes before the oxygen. Nitrogen has the lower nuclear charge, so it should have lower ionization energy as compared to the oxygen. That's what concept says. So those who are saying the nitrogen is the right answer, obviously they are right. This is not the right answer. Okay. Reason I'm explaining to you. First of all, the correct answer is nitrogen. Okay. Guys, write the electronic configuration for nitrogen. It is 1s2, 2s2, 2p3. 2p3. For oxygen, it is 1s2, 2s2, 2p4. Now guys, we can simply look at this. This is 2p3, which is exactly half filled, but in case of 2p4, it is not exactly half filled. I think so I have discussed this point in the structure of atom, that exactly half filled and exactly fully filled configuration are highly stable as we compared those configuration with respect to the partially filled configurations. In case of oxygen, that is a partially filled, okay, which is not the exactly half filled. That's why the nitrogen is relatively much more stable as in the nuclear force on the outermost electrons will be very high as compared to the oxygen. Okay, that's why the nitrogen will have the higher ionization energy due to the extra stable half filled configuration. You can please copy this one. Is it clear to everyone that nitrogen has the extra stable half filled configuration? That's why it has the higher ionization energy. Please copy this. And you can write the explanation as well. You can write the explanations as well. See, because nitrogen has extra stable half filled configuration. Okay. For example, there are few more questions based on the ionization energy that we can compare boron with beryllium. This is the homework for you guys. Boron with the beryllium. Number 2. Chromium with manganese. Number 3. Number 3 is copper with nickel. Number 4, Cr with Cr plus. Okay. Number 5, Cu with Cu plus. Number 6, Cu plus with Cu2 plus. Yeah, this is the homework for you guys. You have to compare the ionization enthalpies for these 6 questions. Okay. In the next class, I'll start with these 6 questions. First of all, you have to attempt all those questions. I want to see your answers, and after that, I'll start explaining. Okay. So please copy these questions, and that's it for today's session, guys. See you next time. Or till then, take care. Bye-bye. Have a great time. Good night. CCPO, I'll talk to the management regarding this one. So please give me some time. Okay, I'll update on it. Okay, relax. Okay. Swagatam, Shillong. Baki all the centers, take care guys.